Hi, this is Mike from Mike's Unboxing Reviews and How To, and on today's video we'll be taking our Hewlett-Packard HP245 G8 and seeing if we can do something with the cooling system with a little bit of help from some Hydronaut. Keep watching to find out more. Okay, so in today's video we'll be taking a look at our Hewlett-Packard HP245 G8 laptop. This is a Ryzen 5 5500U based machine. It does seem to have some issues with thermal throttling and also with temperatures getting a little bit higher than I'd like. Now obviously this isn't designed as a gaming or workstation laptop, it is a general purpose kind of utility laptop for many purposes. So putting this thing under continued stress for elongated periods is not what this was designed to do. Clearly for £300-ish here in the UK, it's not that kind of device, but hopefully we can make it a little bit better. So one of our YouTube viewers, Rick H, actually donated some money to us, to the channel, and said please buy some Hydronaut. So we've done exactly that. Unfortunately in this particular instance, our Amazon driver must have thought he was Ayrton Senna or something, I'm not entirely sure, but sadly the syringe has come through and it's basically obliterated the plastic section here. So we're going to see what we can do, see if we can actually get some out. I'm not going to be able to get all of it out clearly because the syringe is now considerably shorter, but we should be having enough here just to kind of have a stab at it. Also, this video is going to go over actually how to disassemble the HP245 G8 laptop. It's not entirely simple and it's not obvious if you actually just get the unit and you're thinking, well actually how do I get inside it to upgrade it or update it, all that kind of stuff. So we're going to go through how to go about doing that. Some things you will need to do this. Obviously you're going to need some things to prise plastic open because this is a plastic clamshell type design. So we've got these little almost like plugs. Get them with foam repair kits or that kind of thing. You can essentially use anything you want which is kind of sharp and pointy. I would advise against using something like a penknife or that sort of thing, purely because you're possibly going to damage the plastics. So try and get a piece of plastic which is slightly less durable than the plastic of the laptop, which actually shouldn't be too difficult to do. So you could definitely need that. You will also need a PH1 screwdriver and possibly some smaller ones. I'm not entirely sure what we need for the CPU cooling section, so you'll be finding out as I do as we go through the video. So I think that's pretty much it. So let's get on with it and see how it all goes. So starting off with the laptop turned upside down, I've put some microfiber on the desk just to protect the surfaces, that sort of stuff. So what we're going to want to do is to remove the two adhesive strips, which are these ones here, two rubberized strips. These are adhesively attached, and sadly most of the screws that we need to get to are actually hidden underneath those. So we're going to take our little plastic spreader tool and just gently pry at the rubber there just to get it up. And once it starts going, you can probably just pull that off. So just peel that off in its entirety, and I would say probably put it somewhere where you know which one it is. So we're going to say that is our front one, so I'm going to put that on the desk next to me, and now we can do this one at this end. So again, same sort of deal. Just going to go ahead and pry that up in there, and then we can peel this off, and as you can see it's revealed some screws. Now there is actually an indentation on here, so when you're trying to put it back in, make sure that that indentation lines up with that screw hole there. Sorry if I'm getting this around the wrong way because it's a slightly unusual angle to be working on. So to recap, we've got a couple of screws in this end, so there's 3 screws in there, so I'm going to grab a screwdriver for that. I think we should be able to get away with a PH0. Yep, so there's one on this side, and one just here down in the middle, and another one on the end there. So we've got 3 screws there. Okay, put those to one side for now. And then if we spin this round so you can see it a little bit easier. So on this side we've only actually just got the 1 screw, which is awesome. And those screws are all the same, so you can mix and match them a little bit. I don't think they're different lengths. I think they're all, yep, they're all exactly the same length. So if you do manage to muddle them up, it's not the end of the world. Now next thing to do is we need to actually take out 2 other screws which are faced here, as you can see. So move that back slightly, you can see those are just crosshead screws. And these are on a somewhat 45-degree angle. So just get them on an angle and those come out pretty easily. These are a different size altogether. So put those to one side, and that is it for actually fixings. So the next thing to do is to actually remove this plastic cover. Now sometimes if you're very, very lucky, you can actually get away with prizing this open and just basically pulling it away, but a little bit of pressure, that doesn't want to come. So what we're going to do is spin this back round, and what you're going to do is going to get your plastic plugs or picks, whatever you want to call them, and basically just push them into this plastic in between. You can see there's a very small ridge there, so when you push it in, there are sections which lock in. So what we want to do is just push it in and go round, almost like a saw in action, and you'll hear the plastics release as you go round. So when you get to a certain point, you can then move on and go down in another direction. Sometimes it's a little bit more harsh than I would like. As you could hear there, that was a bit of a nasty noise. So yeah, when it gets to this point, you can then start peeling it apart, and I would hold it like this whilst then going down the edges, and you'll find that it releases a little bit easier. And if your unit is very new, you'll probably find this process is somewhat terrifying, because it does make some very alarming noises. There you go. Once you get to a certain point, you'll find that most of the clamshell wants to come off. Once you get to that point, you can, if you want to, fold it over again, and then just lightly just wiggle it, and yeah, you'll hear it just creaks off, and then we can remove this panel in its entirety. So now this is going to reveal the majority of the components here. So if you wanted to do any other changes, such as maybe swap out your battery, change your Wi-Fi card, new SSD, upgrade your RAM, we've done a video on that, so you can check that out if you want to. That's actually quite easy to do. But today what we're going to be focusing on is our cooling system. So this is this large fan here. There's a couple of screws holding it in place there. So you want to be taking notice of those. Follow the heat pipe along, and if we follow that along, then there are 4 screws which are on this kind of spring-loaded deck. So let's start with those. So we'll start in one corner. I would suggest probably undoing the screws and doing it in a crisscross pattern. These again are slightly different, so make sure that you don't mix them up with any of your other screws, just to be on the safe side. You should really, at this point, before you do anything in here, ideally you should remove your battery, or at least disconnect your battery. I'm one of those people that it's kind of do as I do, not as I say. No, well, you know what I mean. So I'm not actually going to disconnect it. Just make sure you don't turn on your device whilst you're performing this procedure. And obviously make sure you don't drop anything metal in here that could potentially short circuit. So that's the 4 screws removed from there. So we can probably find now that that will release up a little bit, possibly. Yeah, there we go. So just prise that up. And this heat pipe assembly actually is separate from the fan. So that is essentially it. So if you want to do any maintenance for cleaning your fan, so if you're maybe not cooling as well as it would do, then make sure this section isn't blocked. And obviously this section here as well, clean that out, make sure that's all good. But there is our processor, and the paste that's on there actually looks like it's pretty much solidified already. That is pretty horrendous. I'm not sure if you can actually see that very well on the camera, but yeah, that is that's not ideal. So we're going to get ourselves some isopropyl alcohol, and we're going to give this a quick clean. So to clean the heatsink and also the CPU, then ideally you want to use yourself some isopropyl alcohol. This was actually kindly donated to us by David Aiken, one of the regulars of the channel. Thank you very much, David. It's actually very useful, and as you can see, we've used a little bit already. So all you want to do is dip it into like a microfiber and you can just use it actually on the paste itself, and it will start breaking it down pretty much straight away. So you can use that. If you want to, you can let it settle for a little bit. Isopropyl alcohol does basically dissolve and evaporate, so you don't want to leave it on there if you can help it, because it will leave a little bit of a residue. But just go ahead and clean the section of the cooler up until it looks nice and clean. So now that is pretty much spotless, as we can see there. Hopefully you can see. Now you can use, if you want to, you can use something like a Q-tip or a cotton bud, as they call them here in the UK, if you want to have a little bit more of precise action on it. But I think for us here, this is going to be actually fine. Just put my finger inside the microfiber and gently try and remove it. So you can use cotton buds or slightly more precision tools should you wish to. That is entirely up to you. There's a little bit of excess there, which is spread around the outside edge. So I'm just going to use the plastic edge here and gently move that away. You want to be careful around the actual processor, because this is basically a naked die or naked core. You don't want to touch, ideally, any of the surface mounted diodes or anything which is around the outside edge. They're very delicate. They're not really supposed to be touched and manipulated very much. So if you can, try and leave them alone or avoid them if possible. If you've got slightly unsteady hands, I would say be very careful, because potentially you can actually damage your processor. Back in the days of when we had the Athlon XP processors, this is essentially what they were like. And when we were just changing things like a CPU cooler, because the actual core is fully exposed, as you can see there, then we would actually crack the core with the heatsink that we put on there. So you do have to be very careful and try not to damage anything. But there that is, nicely clean. So now we're ready to apply some new thermal paste. Okay, so the next part is going to be to actually apply some fresh thermal paste. So I'm filming this the opposite way around of what you're likely to do it, but it's just kind of easier for me. Now I'm going to be using a plastic spatula or spreader. If you're using the Thermal Grizzly paste, you can actually use these attachments which screw onto the end, which will basically kind of flatten out the spread. But because I'm probably going to be sending this back to Amazon because it's basically ruined, so yeah, I'm going to, yeah, you see, I'm going to get to the point where I'm going to push that into a certain point to about there, and there's going to be a load of paste left in the tube, so yeah, that's not great. I do like on this that the actual cap on the end is nice and easy to screw in. So what I'm going to do is just going to put a little bit of thermal paste on the CPU. Which I can't actually see. So that might actually be enough there. So it doesn't need a lot, and actually in a lot of instances less is actually more, because you don't want too much on there spreading out and actually creating too much of a layer between the heatsink and the processor. So what I'm going to do is just spread that around the edges, as you can see there. Let's get a nice smooth and hopefully somewhat even consistency over the entire CPU die, or APU I suppose you'd call this really. And that actually doesn't look too bad at all. I think that's actually alright. Just going to inspect it in this corner, there's a little bit missing. You don't have to be overly concerned about this really, because most of it will just squish out. And the reality of this is the actual CPU is only maximum going to ever draw something in along the lines of like 30 watts of power. So it's not exactly going to be, it's not going to be getting too hot. The idea of this is just to try and improve the performance over the stock thermal compound. Right, so with that done, let's get the whole thing put back together. So what you want to do is to get your cooling section, the heat pipe, and start off in this corner over here. Let it fall into place, and then you should find that the whole rest of it does exactly the same as well. And there we go, just popped in, and all of that's fitted over, and you can see the screw threads there very nicely. See if I can get you a better shot of that. So yeah, you can see there that you can see clearly the threads into the screw holes, so that means it's fallen into place pretty much perfectly. Awesome. So we're going to go ahead now and replace the screws. Now again, what I would suggest with most coolers, you want to try and do a kind of a clockwise fashion. So I'm going to just get one screw in there started. Then I'm going to do one in the opposite corner, which is this one here. And I'm just going to do it up just so it starts biting into the actual spring-loaded mechanism. And then we're going to do another corner. Make sure as well when you're doing this that you don't have any of the little wires which are nearby. Make sure they're not actually underneath or caught, because obviously you could damage the cabling or create a short circuit. And with the last one, we're going to do that right the way down. And then we'll go back to this one all the way down. And I think I'll do this one. And finally, we'll do this one. So at this point now, everything's all good. I would suggest before you put everything back together, just spin the fan, make sure that's okay, and just basically press everything, make sure it's in place. At this point, you would now reconnect your battery if you've disconnected it. Like I said, I haven't bothered, so yeah, that is going to be down to you and your conscience. So now we can go ahead and put the rear cover back on. Now we're happy that everything's done. So obviously those bits at the back where the hinges are. And if you just line it up, get it roughly in place and sort of push down around all the edges, you should find it all locks nicely into place. If you want to, you can open it up again, just have a quick look inside, make sure that everything is where it should be, make sure that all the plastic lines and edges all meet up and match up before you start trying to put screws in. Maybe give it another pat down, but yeah, that looks fine. So close that up again, and what we're going to do first of all is going to do up our right angled screws at the front there, just to get things in the right angle. And this will also draw the plastic in a little bit if it's out of line. So we've got the two black screws which go back into there. Again, these are on something like a 45-degree angle from the chassis, so don't try and put them in kind of completely flat because they'll just cross thread. So those are done. Now we can put in our single screw at the front here. Then we can put over the plastic cover, or the rubberized cover, self-adhesive. Try not to stretch out too much, otherwise it won't actually physically fit back in. There you go, that's that done. Now we're going to spin it round. Hopefully you can see those screw holes okay. Yeah, that's pretty good. And you can start wherever you want to. Get one screw going, put the other one in, get that one going as well, and while that's going we can drop the other one in. And then we're going to put our adhesive strip back on. So again, got that little notch there which lines up with that, so let's spin that round. And if you put it in there first of all, then you should find that the rest of the strip just kind of falls into place. Clearly after time that adhesive is going to wear away, it won't last forever, so probably worth considering looking at other options, maybe some plastic feet just to stick on there. But yeah, entirely up to you. But that is it reassembled. So now we can do some thermal tests. And we'll come back and see if it's actually made any difference whatsoever. Okay, so we've done the testing. Now, I must admit, I've done some very, very basic testing, but it's kind of blown me away already, actually, the difference it's made. Now, there's clearly something in the way that the kind of thermal throttling or the algorithm works for the particular processor that's in here. And I'm actually really looking forward to trying out the Hydronaut actually on other desktop processors, because the difference in here has been nothing short of spectacular, but in a very, very weird way. So normally when we look at improving performance, the thing we're looking at are certain metrics. So one is going to be obviously the results from your tests, so raw physical numbers. But what you don't always expect is that the opposite effect to be true. So what I mean is, actually, let's get straight into it. So Cinebench R23 5-minute loop, on this laptop before and after. So with the pre-applied thermal paste from HP, this laptop's about a month old. As far as I know, it's not been used before I got it. It was brand spanking new. The paste had hardened a little bit. It's not the best quality of paste, so there is that to it. But actually applying the Thermal Grizzly, and I've got my notes here, which are very, very basic, but I just scribbled them down. So this is the before results. So Cinebench R23, our score in the loop test was 5,386 points. Our lowest recorded temperature, including idle from boot up, was 33.5 degrees Celsius. The highest recorded temperature was 82.1 degrees Celsius, which is getting rather toasty. Where it got slightly more interesting is with the turbo speeds. So with the turbo speeds, it actually turboed a little higher, but for less time with this paste. So we were getting the lowest recorded turbo speed that I saw was 2,520 megahertz across all of the 6 cores. And obviously that's the score we got. Where it gets really weird, I don't understand how these numbers work, but they kind of do. And I think I know how. I'll try and explain it after. So our after results, Cinebench R23, 5-minute loop, exactly the same. The temperature in this room is pretty much similar. It's not changed a great deal. It's getting a little bit cooler here on nights with the lights, etc. It's kind of evened out. So 5,947 points. So that is the best part of 600 points extra. That's massive. That's 10% improvement in performance just with some thermal paste. If you look at things like graphics cards and processors, trying to get a 10% improvement in performance is kind of going from a 3060 Ti to a 3070. It's normally a chunky investment. So to get 10% performance out of a laptop processor is awesome. I'm very impressed with that. So, and that actually wasn't the best score I got. I did just a single run after just to kind of validate my results, and that got 6,286. So that is almost, well, that is almost exactly 900 points more than we've got previously. 900 points in Cinebench is no mean feat. Obviously, we'll go into the loop figures more so because that is more relevant before and after. So lowest recorded temperature, including idle speeds, 32.5 degrees Celsius. So we only dropped 1 degree on idle. So yeah, bearing in mind when it booted up and I didn't let it go to sleep and that sort of stuff. So yeah, it is what it is. 1 degree is fine. Happy with that. Where it got really weird is the highest recorded temperature. And I've actually recorded it on the camera, and hopefully you can possibly even still see it now if it's in focus. 97.6 degrees Celsius. That is way, way above what I was expecting. I was expecting it to drop maybe 5-10 degrees overall, but actually it hasn't. It's increased temperatures, so we've now actually got 14 degrees extra. But if you take into account we've got basically 10% more performance, then that does kind of make sense that it's using more power, it's getting hotter. But what is actually happening here is the processor is being allowed to use more power. Because it's looking at the kind of trajectory of where the temperatures are going, with the previous thermal paste, obviously the HP paste, it's looking at the temperatures and they're kind of rocketing. Whereas with the Thermal Grizzly Hydronaut, I would imagine it's looking at it and saying, well, the temperatures are creeping up, but we can kind of cope with that. So it's just pushing the processor faster and faster and at higher clock speeds for as long as it possibly can. Now, when it did get to a certain point, it did thermally throttle, and it throttled pretty hard. But even so, it still managed to beat the previous score by 600 points. So our lowest turbo frequency in the single core test was 3000 megahertz. In the long test here, we're down to, I think it was somewhere in the region of about 2000. So it did drop down quite significantly, but that's just a blip. So on average, the actual throttling speed, or sorry, the actual turbo boost speed was consistently higher pretty much all the way through. So it was around about 3000 megahertz all the way through, and then it dropped all of a sudden when it got to that crazy temperature, then dropped back up again. With the previous thermal paste, it kind of got to 2520 or 2540. It was kind of bouncing between the two, and it kind of stayed there and didn't recover very fast either. That is something else I've noticed. Because the thermal efficiency of this paste is significantly better, it allows the laptop to recover quicker. So Obviously, when you're doing less intensive long-term tasks, so little bursts of speed, it's going to be faster overall because it can recover quicker. So it will boost higher because it knows that it can recover, which kind of makes sense. It's a very complicated algorithm, and the software and the engineering behind it is amazing. And it never fails to kind of amaze me, the results we get from these tests, just by changing something very simple, such as a kind of 12-pound little bit of thermal paste. Anyway, I'm wittering on for way too long now. Massive shout out to Rick H for giving us a super chat donation on our live stream, and he said get some Hydronaut. So I did. Unfortunately it's broken, so we're going to try and get that rectified, but no worries. I will be using this in some other processors to see what other results we can get. But as far as I can tell at the moment, for the money, yeah, seems to be worth every single penny, even if it's someone else's money. Anyway, that's going to wrap things up. Hopefully this video has been interesting to you. If it has, smash the like button. Don't forget to hit subscribe. And don't forget to hit the notification chime so you'll be notified of future video releases. But for now, I've been Mike. This is Mike's Unboxing Reviews and How To. And hopefully we'll catch you in the very next video. Thanks for watching.